Let me just turn off this music. Okay, cool. I wish we had a fade to stop for that. But hello, everyone. Welcome. Um, Excited to have you all here for this week's Fireside Hang. Um, with us today, I'm Lauren. I lead our developer relations team, and Claude is driving the ship today. He is going to be showing some demo code, and we have some really exciting guests to be joining us as well. But before we jump into that, I wanted to introduce you all to a new team member at the Midnight Foundation. His name is Samson, and he's our developer engagement manager. And we are so happy, feel so fortunate to have gotten him on our team. Yeah, just wanted to introduce him and let him kind of meet you all and meet the community. Go for it, Samson.
Awesome. Thank you all for having me. Yeah, I'm really excited to be here and also here for the first time. Again, it's been a pleasure being a part of the Midnight Foundation. I plan to do a whole lot of things from, engaging with the community to do a lot of hackathons. I can't wait to meet you all both virtually and in person. I'm sure we're going to be doing a whole lot of really cool stuff. So yeah.
Awesome. Very cool. Yeah, you bring a ton of experience. We feel super lucky. I just, yeah, there's so much that we're going to see unlock. And I think the ecosystem is really going to benefit from your expertise. But yeah, okay, cool. And I think also, folks, you can expect Samson to be pretty involved in these fireside hangs in the future as well, because it's a great way to kind of be engaged and chat and hear from y'all. Um, and learn what you're wanting to see on the roadmap too. But speaking of that, Claude, this is your day. I'm going to bring up your guests because it's not just you. We have special guests from OpenZeppelin joining us. Iskander and Emanuel, we are so happy that you're here. Samson and I are going to drop. We'll let you all kind of drive and talk smart contracts and fungible tokens, non-fungible tokens, smart contracts, all the good stuff. Take it away.
Okay, thank you very much. So hello everybody. So I'm just going to introduce myself quickly, but I think that a lot of people already know me. So I'm Claude. I'm developer relations at Midnight. So today we're going to talk about tokens on Midnight, and so we have two engineers from the OpenZeppelin team who have been working on contracts to implement tokens on Midnight, and they're going to talk about the contracts that they created. So it's very interesting because it's going to give the ability to developers to create tokens on Midnight. Maybe we can start by introducing Iskander and Emanuel, if you want to introduce yourself and talk a little bit about what you do at OpenZeppelin.
Yeah,
thank you.
We should rock, paper, scissors do those first. You can go ahead.
Yeah. Yeah, I mean, hey everybody. I'm Iskander. I work with the OpenZeppelin team, specifically on the Midnight stuff. And I'm like 80% of my time is building a dApp. It started as a sample dApp, but ending now in a very complex dApp. That's basically building Uniswap version 2 using Compact in Midnight and using the shielded version, like the shielded coins or the shielded tokens, which I guess Claudio will be presenting the unshielded variant out of it. And other than this, I'm working on the contracts library as well as like 20% of the other time. That's all of it, and I'll pass it to M.
Cool. Yeah, my name's M. I've been with OpenZeppelin for the past 3 years and recently transitioned to working full-time on the Compact contracts. I was previously working on the Defender product, which is more like a SaaS kind of thing. So all of the smart contracts, ZK, Snark, Midnight stuff is all super new to me. But yeah, so for the past 6 months, we've been working on the Compact contracts repo. I spend all my time pretty much on GitHub working on that repo. Yeah, just working on making useful contracts for you guys.
Yeah, great. Yeah, and thank you very much. Yeah, maybe before we start talking about the contract, maybe could you share your experience about working with Compact in general? So Emanuel, you mentioned that it was the first time. So maybe how was your experience working with Compact, and Like, what did you like? Were there any pain points of using it?
Right. So prior to working with Compact, I had a little bit of experience working with Ethereum and Solidity and the Ethereum ecosystem. So my mental model was mostly the EVM and working on like Solidity contracts. So transitioning to Compact, it was kind of a big like mental model shift in terms of thinking about how the computation is done and what to prioritize when developing these contracts. For example, in the Ethereum ecosystem, it's very much focused on gas optimization and reducing like the total gas costs for all the operations on the contracts. But in Compact, it's a ZK snark focused system. So that means we are working with like a different paradigm, and that paradigm is in circuits. And so in circuits, we want to make sure that the circuit size is as small as possible, and that makes things a lot faster in terms of compilation time, creating proofs to send to the network, and overall improves the experience for both users and developers by making these circuits as small as possible. So that was probably like my biggest challenge transitioning to working on compact contracts.
Okay, great. And what about you, Iskander?
Well, for me, I think I'm sharing some of the stuff Em said, but I already started before Compact. I wrote some code in Hello 2, like just native Hello 2 or Rust code. And when I jumped to writing compact circuits or something, I found it's way, way much easier, in my opinion. I mean, I know that Compact's still in early stage, but I imagine that I'm seeing the starting point is way easier than using Hello 2 right away or something. So I think it makes writing ZK in a high level way much easier for developers. And I personally liked it. And for the whole development experience for a dApp, I think it's still a bit hard, and especially in the integration side of things for the front end with Midnight.js. I think there's a lot of enhancements can be done there, but overall is good experience, I guess. Yeah.
Okay, great. Yeah, thank you very much. So I think one of you prepared a presentation for the contracts. I don't know which one is going to talk about it.
Okay, yeah, this is me.
Okay.
I don't really have a presentation. I'm just gonna walk through. It's gonna be a lot more chill.
Oh, okay.
I'm just gonna walk through the
It's a kind of
GitHub
presentation.
repo. But yeah, so this is the compact contracts repo. What I would recommend, like for someone who wants to start developing with compact contracts, the first thing you should do is to go through like the community support documents that we've created. We spent a lot of time making these documents to make sure you guys get up to speed with the repo as quickly as possible, and keep things efficient in terms of opening issues, when to open an issue, when to create a discussion, that sort of thing. We're not going to go through that today. It's a lot of you could do that in your own time. But yeah, like the meat of the compact contracts repo is right here in the contracts directory. This is where we have all of our contracts. Right now, in the beginning, we were focused on creating token contracts and like basic security mechanisms. So right now, you can create like a fungible token contract, multi-token, non-fungible token, and we also have some basic security contracts available, such as access control, where you can like control who can call certain circuits in your contracts, as well as ownable, which is a much simpler version of the access control module. We also have a couple of utility contracts over here. For example, initializable, we use this a lot in our contracts to sort of mimic. So in Compact, there is no, well, there is a constructor, but it can only be used at the very top level of your contracts. So all of the contracts that you're importing, they need to like initialize state in that top level constructor. So we've created this initializable contract to like help you do that and properly initialize those contracts. We have the pausable contract as well, which is kind of like a safety mechanism to just pause all operations on contracts in case like a critical bug is found, that sort of thing. We also have all of these documented on the OpenZeppelin website. You can just go there really quick. You can find the documentation over here. Yeah, so docs.openzeppelin.com, contracts compact. Yeah, so we have all of these modules very thoroughly documented. You can just go through here and check them out on your free time. We also, well, at least like for me, I wrote this section called ZK Circuits 101 as sort of like a way to like, not only for me to like understand how working in compact circuits should be thought about, but also for anyone coming to work with our contracts. So in our modules, in our API reference, we have this sort of documentation right here called constraints. And many people coming from other ecosystems, like not ZK focused ecosystems, they'll like see this and be like, what the heck is this? Like, why do we even care about this? What's the purpose? And so all of this is documented here in like the ZK Circuit 101 page. We also have a really important page called the extensibility page. And this is more like how we designed our contracts and like how you should be importing them into your own contracts and how to use them. We have a whole bunch of documentation here that you can go through later. And yeah, that's pretty much the full sort of overview of OpenZeppelin contracts right now. I'll let Iskander take it away so he can talk more about the DApp side of things.
Yeah, actually, I haven't prepared yet a presentation or something. I think I will talk out of my head about some points since the DApp is still a private repo. So like I started developing at Uniswap version 2, like thinking how to make it private somehow. And then there are many ways you can think of how to make public MM private, yet to still balance the prices and balance the trust that people do with MM, with public MM. So I thought at the end of using UTXO model and having the reserves public. So with keeping the same liquidity mechanics of Uniswap that it uses. So one of the first challenges I faced was like using a math library or needing a math library for doing complicated equations that are needed for calculating the liquidity, transformation and stuff like this. So that was the beginning a challenge, like you have to support this. And I remember the early days, like if you're jumping from solidity, you'll think of variables as UN 256 bit size. But when you go to compact, you'll see the current maximum variable you can have is up to the field size, which is 254. So if you're doing combination, like multiplication between two variables from like 128 bits each, then the total value will be exceeding the field size. So you'll have some sort of like overflow at the end. So in order to mitigate this, you might be interested in building another way of dealing with big numbers in mathematics. So that was just a technical challenge, just to calculate the correct equations, calculate the correct equations for the liquidity. Another thing is just thinking a bit differently about the sending and receiving with specifically the shielded tokens, and how you should be taking care of saving them properly in your ledger, and not like to have, because I remember like doing mistakes and saving the reserves in a bit wrong way, that at the end you have wrong Merkle tree index for the shielded tokens. You have them saved in the ledger, and then when you try to swap them later on, they are not swapped because they have wrong Merkle tree, and then you didn't actually save them in the ledger in the right way to the correct Merkle tree index. Yeah, as it's still ongoing thing, I didn't yet write a feedback. I think I should write feedback detailed and be published in the docs soon, like the OpenZeppelin docs. And the current state of the docs of this application is pretty sort of pretty finished. There's just one bug. We're trying to figure it out with the Midnight team. And other than this, it should be released sooner. And then we should do another session specifically for it, because I think it will be a very complex application on Midnight.
And when you're talking about an application,
and
so you're building...
one of the other big changes I can think about is the complexity of circuits, which you have to be always taking care of. I remember add liquidity circuit has huge size that in order for me to just do the transaction, I'm keep waiting at least 3 minutes on the browser just for that liquidity to finish the computations from the local proof server that I'm using. So doing optimization, this is really needed in this case to decrease the time that users will spend generating the proof, and also the gas cost later. Also, if you're thinking about the block time, is pretty different from how is it in Ethereum, because you're thinking about the block time in ZK, you're running the circuit locally to generate the proof, so you can't have the block time stamp that your transaction will be in, because you're generating the proof and then you don't know which transaction and which block will have the proof for your will have the proof that's in your transaction in the future. So you need to think about it a bit differently. So yeah, that's some points to say. But yeah, later on, I think when it's ready, we should make a more detailed presentation in a good way.
Yeah, sure. Yeah. So when you're talking about dApp, so you're working. Can you hear me? Yeah.
Iskander, can you hear Claude?
Can you hear me?
Oh, I
I'm
don't
feeling
think
that you don't hear me. I think it doesn't hear us. Okay, so maybe okay. He has some audio issues. Maybe I have a quick question for you, Emanuel. Would it be possible to have like a quick introduction of the interface for the tokens, so for the fungible tokens and the non-fungible tokens? Above all, the non-fungible token, I'm very interested in it, because we also have another team that's working on the standard on Midnight. So it would be very interesting for the people watching, you know, to understand how your approach is and how you think about the standard, the NFT standard on Midnight.
Yeah, sure. Give me 1 second. I can pull up my screen again. We can go to that interface. Can you see my screen now?
Yes.
Yeah, so when we were creating the fungible token contract, one of the design goals was to make it as similar as possible with the current fungible token standard on Ethereum, so the ERC20 standard. But due to the huge design differences between Ethereum and Midnight, Ethereum being like EVM focused and Midnight being more like a ZK, we couldn't exactly like create a one-to-one sort of interface when we were creating the fungible token. And this is not just the fungible token, this is also the non-fungible token, the multi-token, the access control. All of these contracts, they are not one-to-one with the Ethereum sort of representations that a Solidity developer would normally be familiar with. And that being said, these contracts aren't like set in stone as sort of the go-to standard for how like a fungible token should be created. Another important thing to note is that these fungible tokens are smart contract based tokens. So all of the state and representation of the token is held in the smart contract. And Midnight also has this cool thing called UTXO coins or tokens. And it's very much up in the air of like how we should represent like a fungible UTXO token. Like, what does that look like? We have no idea yet. Currently, there are some big design or feature hurdles preventing us from being able to really experiment with that at this time. But in the future, once we have more control over these UTXO tokens, because another thing to note is like these UTXO tokens operate like cash, like physical cash. Like you give your like $20 bill or 20 euro or whatever to someone, and then they can light that on fire or like just give it away. Like you can't control what someone does with that cash once you give it away. So until we have some programmability for these UTXO tokens, we're a bit limited in sort of like the designs that we can create with them. We're still working on some interfaces and research ideas, but yeah, that's pretty much where we're at right now with the UTXO tokens.
Okay, and what about the non-fungible token? Can you show it quickly?
Yeah, so non-fungible token, same thing as a fungible token. So the interface attempts to mirror the ERC 721 standard as best as we could. I believe there are probably some differences in how it's implemented. Let's see, we probably note it over here. Right, so like Iskander was saying earlier, in the original ERC 721 standard, the accounting is done with uint 256 integers, but we don't have that available in Compact right now. So we chose to use the uint 128. And in the future, once we have a robust math library, maybe we can improve this and bump it up to 256. But until then, it'll be 128 for now. Another thing is in the original ERC 721 standard, there's this base URI method that allows a developer to concatenate like a URL, like a base URL with something like a ID or something. But native string operations in compact contracts are not supported at this time. So we decided to throw that out and take a different design approach. Instead, I think, let's see. Yeah, so instead we have, a set token URI. And so you call this set token URI to set like the specific URI for a token once it's minted. Generally, you do this right after you mint the token. You set the token URI, and it's good to go. But that's all up to the developer on how exactly they implement this. Another really important thing is in the ERC 721 standard, there are events. So like once you mint a token or something like that, there should be an event emitted to notify everyone on the blockchain that something just happened. But Midnight doesn't have events at this time, so we decided not to do that. Yep, uint 256. Oh, another thing is, so there's no way to define like contract interfaces like you can in Solidity at this time. And what that means is we can't really implement like a ERC 165 standard. So you can't call into a contract and understand that, oh, this is like this contract implements the ERC 20 or ERC 721 interface. Like there's no like there's no introspection. So a contract can't tell you that it is an ERC20 or ERC721 contract, which makes it a little bit unsafe to work with at this time. But we have well-defined methods that let users, developers know, like, hey, like, we don't have this available. Please use these methods with caution. For example, like if you send like a ERC721 token to a contract that doesn't support the interface, it's gone forever. So developers need to be make sure you read these docs like very well and understand the limitations of the contracts at this time.
Okay, perfect. Yeah, thank you very much. Yeah, it was very interesting, like to know a little bit more about the tokens and how they're supposed to work on Midnight. So maybe talking about how tokens work on Midnight, I can show a little bit of code that I wrote. In the DevRel team, I write some template applications for developers to use as a base to build upon. So the templates are, we already have 2 templates, and in general, they're like very simple contracts and applications that are more for demonstration purposes. So at the moment, I'm working on a very simple DEX that works as an automatic market maker. So it's a very simple one with 2 tokens. The 2 tokens are integrated in the contract because at the moment there are no contract to contract interaction on Midnight. And let me see if I can share my screen. Okay, I think that works. Okay, so that's the contract in Compact. So I'm using the contracts that that OpenZeppelin wrote. So the fungible token contract. So here for this example, I just copy pasted it and I import it directly. I think that you have in your examples online, you have an npm package. Is that correct?
We do not, like, you can't get these contracts from npm at this time.
Oh, okay.
I believe, I think what you're talking about is like we import the compiled contracts from node modules. Is that what you're talking about?
Oh, okay, yeah. There was a path from the node modules to import the contracts in the documentation. So
right. Yeah, that's just like the compiled contracts that you get like once you run the compact compiler. You don't have to do that. I think honestly, like the recommended way to work with these is just to copy and paste from the repo.
Okay. Yeah, so that's what I did. So I copy pasted it, and I'm using them. So I'm importing them, and as you can see, there are 2 tokens in the contract: the foo token and the bar token. So because as I was saying, it's not possible to interact with the other contracts on Midnight at the moment from a contract. Then the tokens are implemented directly in the contract for the DEX. And then the contract has different values in the ledger. So there is an admin value. The contract also allows users to claim tokens. So it's possible to send a transaction to get some tokens to play around with them and to try the DEX. So that's what this set here tracks. Also, so that you're going to see that there's a very simple liquidity providing system that's not really like what you would see in production, where in production, you know, when you provide liquidity, you get some tokens that proves that you provided liquidity. Here, you just send back the tokens to the contract, so the contract can use them to swap between the 2 different tokens. But whoever sends the token to the contract is going to be recorded in this map called liquidity providers. And then when the contract is created, we also set the amount that the users are going to be able to claim for the tokens. There's going to be also a witness here in the contract. So the witness is used here because because it's not possible to make a division in Compact at the moment. So there is a workaround to check that when you swap tokens, there's a formula that you have to use that contains a division. So there is a workaround for that formula where we ask the users to provide the amount that they want to swap and the amount that they expect to receive, and then we compare them with different values from the contract to make sure that they are correct. So here in the constructor, we just so that's how you use the fungible token from OpenZeppelin. So you see that when I import it, I prefix it, so I have 2 tokens here, and that's how you use it. And as you were mentioning, there is that initialize function that you call to initialize the state of the contract and to make sure that the contract is safe to interact with. And you pass here in the constructor different values to the name, the symbol of the token, and also the decimals. The admin is taken from whoever is deploying the contract. And then the contract is going to mint some tokens. So both foo tokens and bar tokens are going to be mint. So that's also a function from the fungible token. And as you can see, so kernel self in Compact is going to return the address of the contract, so this one here, and it's going to mint whatever supply that we want to have for the tokens. And here we set the amount that the users are going to be able to claim. Next, let's have a look at the circuit to claim the token. So here you will be able to claim 100 tokens. So it's very simple, compact. So we first you have to tell the contract which token you want to claim. So it's not possible to claim both foo and both foo and bar. So you have to choose if you want to claim foo or bar tokens, and that's what it does here. I have a personal convention that I don't know if it's ever going to be best practice, but when I disclose a variable, I disclose it in a variable with the same name, and I put a $sign in front of it. So later in the code, if I have to use that variable, I know that it's disclosed, and maybe if I don't want it in a place where it's disclosed, I can rearrange the code. So that's what it means here. Oops. And then we get the address of the user. We just check that the user hasn't claimed already some tokens. And then according to the tokens that they want to claim, we're going first to get their balance. So here we're using the balance of function from the fungible token, which is very useful here because it asserts in the background that if the user already has an entry in the map, and if it doesn't, it returns 0. So the contract is not going to fail when you do that. Otherwise, you have to implement it yourself. But here, the contract takes care of checking that the entry exists in the map, and if it doesn't, it just returns 0. And then with that, after that's done, we can transfer the tokens from the contract to the user. So there are different transfer functions implemented by the fungible token contract. So this one allows to put from address. So it's going to be from the contract to the user and the claim amount. And this transfer from function returns a Boolean value that we can check that everything worked. And if it didn't, then the contract is going to fail. And same thing if you want to claim bar tokens. Then we have the functions for the liquidities. I'm just checking if there are questions. No, it's okay. So we have 2 functions for liquidity. So one to add liquidity and the second one to remove it. So as I said earlier, it's not really for production. It's more like just to implement some more circuits, not to provide a a more fleshed out example, for developers. And so here to add liquidity, you just provide some amount of tokens, and the same way the contract is going to behave differently if you're providing food tokens or bar tokens. And once again, we check that if the user already has a balance, so we can transfer the tokens. And here you can see that from fungible token contract, we use the transfer method, because when you add liquidity, it's going to come. The from value is going to take it from the sender of the transaction. So we just have to indicate the recipient of the tokens, which is going to be the contract, and then we can check if everything was okay. And we also use that liquidity providers map to keep track of who provided liquidity, and that's what we're doing here. So that liquidity providers map is in the contract; it's not in the token, and that's why we have to check first if the user already provided liquidity, and if they didn't, we can just insert the new value, and if they already had, we have to fetch the value that's already in the map and update it. The remove liquidity is even easier. So we just like the same steps, but backwards. We have to check if the user has liquidity in the contract, otherwise the contract core is going to fail. And then we subtract the amount that they are removing from the liquidity provider's map. And then at the end, we transfer according to the token that was removed. We transfer the tokens from the contract back to the user. Then here, for example, it's a very good example of how easy it is to implement your own contract with the fungible token contract from OpenZeppelin. For example, here, if you want to transfer foo tokens, you just have to call the foo token transfer and pass it the recipient and the value. So you don't have to implement anything to transfer tokens. Everything is already implemented. You just have to expose the circuit. Same thing to transfer bar. So here we have a circuit that's not an entry point, and that's going to verify that the swap of tokens is correct from the values that are going to be provided through the witness. So there's like a lot of math. I mean, a lot of math. For me, it's a lot of math. No, I know for other people, it's very simple math. But there is some math involved here. That's checking, as I was saying, that the two values that are provided by the user, so the amount of token that they want and the amount of tokens that they provide, is correct according to the amount of tokens that are in the pools at the moment. So that's how that very simple AMM works. So there's a very simple formula that's here. These two lines that calculates the price of the token that you want to buy according to the one that you're selling, and the amount of tokens available in the pools at the moment. So that circuit does that, verifies that the amounts are correct, and these amounts come when you call the swap circuit. These amounts come from here. So the amounts to swap is that witness that we have at the moment. So a witness is a function that's going to get values, so private values from the user. So you have to verify them to make sure that they are correct. And once they are correct, it's just the rest of the contract code is just about updating the different balances. So of course we verify also that all the amounts are not zero before verifying that the amounts are correct. And then we can use some functions that are provided by the fungible token from OpenZeppelin. So for example, balance of to fetch the amount of food that are in the pool at the moment. Same thing for the amount of bar in the pool. And then once again, because we have that design where we have to implement the two tokens in the same contract, we have two different branches in the if condition. So let's check, for example, if the user wants to sell foo, so those are the tokens that are provided. We assert that there are enough bar tokens in the pool. So the tokens that the user want to buy. And the contract is going to fail if there are not enough bar tokens in the pool. And then we can use those functions from the fungible token contract to transfer the tokens from the contract to the user, and the bar token from the user to the contract. So you can see that we use different functions for the different swap of tokens. So you just have to call these functions, and everything is done under the hood by the fungible token contract. All the safety checks, that the balances are correct, or that the contract is correctly initialized, all that kind of things is handled by the fungible token contract. And for this one, we just return the new amounts in the pools. So that's mainly for the interface. So when the contract is done running the circuit, you can, on the interface side, you can retrieve the new amounts of tokens in the foo pool and in the bar pool, and you can, for example, display it for users, or you can use it again. So that's the contract that I've been working on. So this contract is not public yet. So it's I've been above all that the fungible token. I think your contracts were published like maybe 2 weeks ago, something like that. So I had to re-implement the contract to use it, because I really wanted to use it. It's a great example. So the text contract I'm working on, it's not available yet, but I'm going to make it available very soon in the Midnight Network GitHub, and people are going to be able to play with it, and like it would be also good to get some feedback. And of course, it's a very simple example, so you're welcome to improve it and add some more features. And yeah, so that's it. That's it for that. I don't know if I think there are a few questions in. Emmanuel, is there anything that you would like to add, or?
I guess the only thing I would add is right now Compact is still in like a very it's still growing. Like it's not like a stable language yet. So in the future there will very likely be big changes to the like fungible token, all of the contracts really, to adjust for the new Compact features and changes in Compact. So just be aware that there will very likely be breaking changes quite often with these contracts. So yeah, don't use them for any like real. I know we're only on testnet right now, but like yeah, they have not been audited. Be very cautious about using them for any like production applications, that sort of thing.
Yeah, and regarding that, so I think that there is a question in the chat, and I think it's about that. Is there any plan to have like one source of authority about those contracts? So, for example, you see at the moment I have to copy paste them, but what about you make a change in the GitHub repo while I'm using it and I'm not going to know about it? Is there some plan, to have that maybe like an npm package, or to distribute it, have some version control, so we can see, so I don't have to go through the contract, to see if there were changes?
Right. Yeah, that's a really great question. I think we are punting this sort of problem over to the Midnight Foundation and like waiting for better tooling to become available. And like once that tooling becomes available, it's more like and by tooling I mean like something like Forge, or like a developer framework really. Once that tooling becomes available, we will be happy to integrate as soon as possible. I think we in like the near future, because that might take a while. In the very near future, we might publish these on NPM. We haven't really thought about it too much, but yeah, we will definitely be open and communicative about that once we do.
Perfect. I think Iskander wanted to add something. I don't know if he's. Are you muted or I cannot see you? Like, I heard some noise. I don't know if it's from him or I know. I think he has some issues with his sound and microphone today.
I can answer a question about the contract maintenance documentation that Sergey asked. Yeah, we haven't really thought about that too much. There's no documentation about how to maintain these contracts vis-a-vis the contract maintenance authority. It has been something that we have discussed and thought about a little bit, but at this time we're really focused on delivering like really core contracts such as like tokens and access control and like those kinds of things. It's not on our roadmap at this time, but we can certainly consider it in the future.
Okay. Yeah, so I got the question from Iskander. He was asking about about the disclose in my contract. Let me share my screen quickly again. I think it's is it sharing or okay, now it works. Yeah, so I think it's a new feature of Compact. I mean, from one of the latest versions. Like for example, let's have a look. Yeah, for example, here add liquidity. So now in Compact, these two lines. Now Compact, the Compact compiler forces you to recognize that some values are going to be visible when you use them in the contract. So here those values. So my understanding is that those values become visible because I save them in the ledger of the contract. So the amount and the token. Wait a second, maybe not the token. Okay, that's actually a good question. So I'm pretty sure that I disclosed it because the compiler complained about it. I'm not really sure why it would complain about it here because it's just being used here. Let's have a quick look at something. It's also, I don't know if you guys use the new Compact suite. Oh yeah, of course. Okay. But now it's a little bit easier to use Compact. Yeah, so yeah, you see, Compact is complaining that yeah, that's that value here, the token value. So yeah, that's actually a great question because I was pretty sure that it was because the value would be visible, but I don't really. Oh, maybe it's because I pass it as an argument. So I think the argument is visible in the transaction. I think I'm going to have to ask about it. That function also is very new. So yeah, I'm not sure about it. I think I'm going to ask about it, and I will publish it somewhere. We should make it a little bit more, a little bit clearer what that function does and on which value it works.
Yeah, can you hear me now? I hope
Oh,
it
yes, I
works.
can. Yeah.
Oh, finally. I'm sorry for this. Yeah, thank you for explaining. It just, I always find it using of this clause whenever I have witness function that's like, for example, like division. We were doing division using a witness function, and then the result of the division, I have to use this clause with it because this is coming from a witness function if I'm returning it out of the circuit function. Yeah, so it would be great if we highlight because it's a very important keyword that will leak your private state if you use it without being careful.
Yeah, exactly. Yeah, yeah. It's also very new, so I don't think we have a lot of documentation about it. So it's a good opportunity to have something clear about what it does. And yeah, I see a comment in the chat that arguments are definitely visible. So yeah, the compiler wants you wants to force you, to be aware that that value is visible and tagging it with that function disclose. But it's worth having a better look to understand what it does. Okay. Are there any questions, or do you have any more comments that anything you would like to add? No?
Just like another response to Sergey, I just opened up a GitHub discussion regarding the maintenance and upgradability vis-a-vis contract maintenance authorities. Sergey, please go to the GitHub, the compact contracts discussion section, and feel free to let us know the issues that you're running into and like what you would like us to provide for both you and the community. I think this is a really important discussion to have, so I went ahead and opened up a GitHub discussion about it. I recognize that the contract maintenance authority, it's unique to Midnight, the Midnight ecosystem, but it's a very important primitive to like understand and create tooling for. So yeah, I think this would be like a really fruitful conversation to have.
Yeah,
Okay, perfect. Yeah. Yes, go ahead.
May I just add something in the end? Looking at the sample contract you wrote about the MM using the unshielded variant, seems to me way easier than the unshielded version if you're using for also doing some sort of like a DEX side of things, because you really need to be careful with, as I mentioned earlier, like transferring tokens or shielded coins, and to make sure that they are transferred correctly and they have been converted from a coin info into qualified coin info. And this qualified coin info means it's saved properly in the state Merkle tree, the global state Merkle tree, and having a correct proper Merkle tree index. So I think it's a very good chance when I have the DApp ready that I'm working on, that we can do another call of this and I can present what I had in a shielded way.
Yeah, that would be very interesting. Yeah, let's keep that in mind. And when you have something ready and you want to present it, yeah, we should have another one. Okay. Well, I think that's it on our side.
Thank you, everyone, for joining today. This was an excellent conversation and something I think folks will be able to return to in the future as well. And we have a lot of action items as well. So yeah, I will end the stream now and see you all online. But thank you again, both for joining us. It was really fun to have OpenZeppelin as a partner on the stream today.
Yeah, and thank you to everybody who watched the stream. See you.
Yeah, good chat today too.
Thanks, guys.
Thank you.
Bye.
Thank you, everybody. Ciao.